Welcome back. This is an Aleks training video on using Le Chatelier's principle to predict the result of changing concentration or volume. Le Chatelier's principle is dealing with disturbance, and in chemistry that's called perturbation. So if you perturb someone, you bother them, you disturb them. So if you disturb a reaction that's at equilibrium, then what will happen is that temporarily, for a very brief time, you'll have a temporary forward reaction rate will increase. Okay, so if you bother something, and in order to reestablish equilibrium, temporarily you may end up with a forward reaction that speeds up a little bit. Okay, can become higher than normal. Or in order to overcome the disturbance, it might be that the vessel will move the reaction rate, the backwards reaction rate, up a little bit, make it faster temporarily, and then it reestablishes equilibrium. Okay, so it basically just gets rid of the disturbance. I think of it like this. If I have a pile of water and a dip of water, so let's say I have a wave. So I have, here's the normal sea level, and I've got a wave up here and a dip where there's no water there. The water will go from here into there. It will always go from high pressure to low pressure. It's a disturbance, it's a perturbation. So in order to reestablish equilibrium, which would be a nice level sea, the wave would fill the hole. So if you have a high concentration of oxygen or sulfur dioxide or something that is added to the vessel after it's reached equilibrium, it's actually like a pile of water that has to fall away from itself in order to reestablish equilibrium. Okay, so wherever the concentration is, it's going to go the other direction. So if you increase something on the left, it will push the arrow to the right. It will shift the equilibrium to the right, which will temporarily increase the rate of forward rate. Okay, if you increase the concentration of something in the products, it will temporarily shift it to the left until it reestablishes equilibrium. Okay, so let's look at the first one. The first question, it says some oxygen is added. So oxygen is a reactant. That means if I have a pile of oxygen, it's going to, in order to reestablish equilibrium, it's going to shift it away from where the oxygen is piled up towards the right. Since it's on the left, if I have a pile, it'll shift it to the right. Okay, so what's going to happen? You have all these questions to answer. Some oxygen is added. Let's do the shift in equilibrium first. If oxygen is added, that piles up oxygen on the left, it will want to compensate by shifting it to the right. So the first question I would answer is it shifts to the right. Think about it all going to the right. Now, momentarily, let's just review all the different elements. If I shift to the right, what's going to happen to this guy? Well, it's going to lose, okay? If I shift to the right, what's going to happen to this? Well, this is going to gain. Okay, so the pressure of all these will be dependent upon what happens when you piled up the oxygen. Since you piled up the oxygen and it moves away from oxygen to reestablish equilibrium, then this guy's going to drop because it's going away also. Well, what's going to happen here? It's going to gain. So let's do the change in composition. The pressure of the SO2, which is a reactant, will do what? Well, if it shifts to the right, then it's going to go down. So this will go down. What's going to happen to the pressure of the SO3? Well, it's a product. So if it's shifting to the right towards the products, that pressure will go up because more products are being made. Okay? So that first one is pretty straightforward. The second question is kind of, instead of the pile, it's the dip. So if I have a dip, I have a lower concentration than normal, then the equilibrium will shift towards the hole, just like the pile shifts towards the hole in the wave. All right. So if you have something removed, then the arrow is going to come towards that side, whatever side is removed. So this is saying some of the SO3 is removed. Well, SO3 is a product. So if the SO3 is a product and it's removed, then the arrow is going to shift towards the products in order to compensate for that. If it shifts from the products, what happens to all the other stuff? So your first question is, well, first of all, where is it shifting to? The shift in equilibrium, some of it's removed, that's a product, so it's going to shift towards the right in order to compensate. So if it shifts towards the right, what happens to the pressure of the SO2? It's a reactant. Well, if it's shifting away from the reactants towards the products, then this is going to go down. Okay, what about the pressure of the oxygen? The oxygen is a reactant. If it's shifting away from the reactants towards the products, then it also will go down. Now, I think of those two kind of together. Concentrations. If you play with the concentrations, if you pile up a concentration, it'll go away from that concentration. If you reduce a concentration, it will go towards that concentration. Okay, I think of them as kind of the same. The other one is a little different. The volume of the vessel is increased. All right. Instead of thinking of volume for a minute, think of pressure. If I increase the pressure, Le Chatelier said that the equilibrium is going to shift in such a way that overcomes the disturbance or kind of compensates for the perturbation. So if I increase the pressure, it's going to want to do something to make the pressure less. All right, so let's look one more time at the balanced equation. How many moles of gases do I have on the left? I have 2 plus 1, so I have 3 moles on the left. How many on the right? I have 2 on the right. So if I have a high pressure, what's going to happen? It's going to move towards whichever one has lower number of moles because it's crowded. High pressure means it's crowded. So instead of having 3 things, it's going to adjust itself so that it only has 2 things. So it compensates for the increase in pressure. So if you increase in pressure, it moves towards the lower number of moles. If you drop the pressure, it will increase towards the higher number of moles because it fills in the space better. Okay, you've got more open space, and so it fills in the space by having more molecules rather than having fewer molecules. So this is saying the volume down here, the volume of the vessel is increased. What happens to the pressure if you increase the volume? If you make the room bigger, what happens to the crowded air? It's going to be less crowded. Okay, so if you increase the vessel, the pressure drops. Well, what happens up here arrow-wise if the pressure drops? If the pressure drops, I have more space, so I want more things to fill it. So I'm going to go towards the bigger number of moles. I'm going to go towards the 3 instead of the 2. So if the pressure drops, I'm going to head towards the 3. If the pressure increases, I'm going to go towards the 2. So how does that in volume? If the volume is increased, that means the pressure drops. If the volume is reduced, then the pressure increases. So there's a couple things to think about. All right, so what's going to happen if the volume is increased? If the volume is increased, then the pressure drops. If the pressure drops, it goes towards the bigger number of molecules, so it's going to go towards the left. So the first question over here is that it'll go towards the left. All right. If it goes towards the left, see, I actually like this question first, the shift in equilibrium first. If I do that one, then I can answer the other one easier. If it goes to the left, what happens to the pressure of the SO3? SO3 is a product, and if it shifts towards the left, then it must go down. Okay, lots of questions, but I think if you get your mind on the right track, I think you'll be able to answer them okay.